All right, hi everyone. All right, let's get started on our practice test here. These first four, the interval notation and for each subset described, sketch the subset on a number line. So we get a number line. Express the subset as an inequality if it is in interval notation, like these two, or in interval notation if it is an inequality, like these two. And then state whether the subset is bounded or unbounded. So read those directions. A, sketch the subset on a number line. Okay, so I've got -1, 0, 1, 2. All right, didn't plan ahead very well there. Here's 6, here's 7. I'm going to go 8. All right, x is less than or equal to 7. So 7, here's the critical point there. And I'm going to include that point, so that's why I color that in. And less than or equal to 7 goes this direction, so I'm going to make a heavy arrow here. And even emphasize the point of the arrow there, like that. Now, it is in inequality form, so we want interval notation, which means the left side of my notation, my interval, is negative infinity, and the right side is 7, and include 7, I'll use that square bracket. We can't measure this one, so this one is unbounded. Now on this one, we have an inequality. I'll put -3 here, -4, -2, -1, 0, 1, 2, 3, 4. Again, planning needs to be a little better. I always like to go at least a little beyond. Now x is greater than -3 and less than or equal to 4. Now less than or equal to, we'll color that one in. We'll leave that one open. And I will shade between these two. The left side of the interval does not include the -3, but goes up to it. The right side goes to 4. And -3 to 4, this is interval notation. This one, we can measure the distance between the left and right side. It is bounded. This one is in interval notation. I'm going to put it on the number line. I'll put -2 here. I'll put 5 here. And write those out. I'm not going to do that on this one. Open circle, closed circle. Square bracket goes with the closed circle. The curved bracket goes with the open circle, and we'll shade between them for this bounded interval. And then -infinity to 6. So if I put 6 here, I want an open circle because that's a curved bracket. And -infinity is the left side, which is going like so. Okay, and this is 5, and 4, and 3, and 2, and 1, and 0, and negative also. Okay? This one is unbounded. Okay, so just remember some of those things. All right. Next we have some simplifying to do with exponents. And we want to rewrite so that we have positive exponents. I like to do it in 3 parts. 12 over 4 is 3. A to the 3 minus -2 when it's division. And b to the -4 minus 1. -4 minus 1. We're looking at 3. 12 divided by 4, that's 3. 3 minus -2 is 5. And that's b to the -5th. And when I write my final answer, I have 3a to the 5th over b to the 5th. The negative exponent to make a positive exponent. Okay, I'm going to do the power to a power here first. So I've got 5c to the -5th times 4 squared times c to the 3rd squared. That square needs to go to the 4 and to the c to the third. And so that's 5c to the negative 5th times 16 times c to the multiply exponent, c to the 6th. Okay, I got my 5 times 16, and then my c's, negative 5th times c to the 6th, and 5 times 16 is 80. Negative 5 plus 6 is 1. You can leave it 80c or write 80c to the first. All right. Now, I'm going to rewrite 72 as 6 squared, which is 36, times 2. And you can get that different ways, but we're going to find the square root, and I need squares. So that is 6 squared times 2, 36 times 2. I'm going to take a to the second power squared. That's a to the, well, a to the fourth power. A to the fourth power squared. I want to get a square out here. And I'm going to take b to the second and square that. That's b to the fourth. And then I have another b there. So the part that can come out, 6 squared, can come out as 6. Square root of 6 squared. That's going to stay, square root of 2. Square root of a to the fourth squared. The square root and square cancel out. So I have a to the fourth out here. B squared squared, that is b squared. Take care of those parts, and the parts that's left is a 2 here and a b here. And since that's the fourth power and that's the second power, especially that one, I don't see the need putting absolute value because of those fourth powers there. Now number 8, this is cube root. We have a negative under here with an odd root. That's okay. The cube root is going to be negative. I'm going to think of perfect cubes. Now 5 to the third power is 125. That does not go in. And I'm pretty sure 4 to the third power is 64. But 3 to the third power is 27. And I think if you take 27 times 5, you're going to get 135. So I'm actually going to use, and that's 3 to the third. Negative 3 to the third power is negative 27. So I'm going to use that. Cube root, negative 3 to the third power, and then times 5. And then I'm going to times by x to the third, because I want a cube root and third power to match up and have x to the second here. So I'm looking at the cube root of negative 3. That's negative 3. Cube root of x squared is x. It's an odd. I don't need an absolute value. I don't want an absolute value, actually. And then I have the 5 and the x squared here. All right. I'm going to simplify this one. 48 is 16 times 3. That's 4 to the second times 3. That's my biggest square that goes in there. So it's 2 square root of 4 squared times 3 minus 3 square root of, now that's 9 times 3, so that's 3 squared times 3. There. All right. Square root of 4 squared is 4. So I have 2 times 4 times square root of 3 minus 3 times 3 times the square root of 3. So this is 8. That's a 3 there. Okay, that's 8 radical 3 minus 9 radical 3, which is negative 1 radical 3. And I'm just going to write that as negative radical 3 there. All right. Number 10. We're going to rationalize the denominator. And I'm going to write this as 1 cube root of 5 squared. 25 is 5 squared. And I need a third power in order for that to happen. So I'm going to multiply this by a 5. And I just multiplied the bottom by the cube root of 5. So I've got to multiply the top by the cube root of 5. And that's what I've got here. The cube root of 5 over the cube root of 5 to the third. Just writing out this step here. Cube root and cubes cancel out. So cube root of 5 over 5 is the denominator, the rationalized denominator. Now, I've kind of started here. I'm going to take the square root of 2 plus the square root of 3, and I'm going to multiply it by the square root of 2 minus the square root of 3, the conjugate. In this one, when we have two terms like this, and what do we have? We have 6 radical 2 minus 6 radical 3 on the top. On the bottom, it's the square root of 2 times the square root of 2, which is 2. The outside is the negative square root of 6. The inside is positive square root of 6. Those cancel out. And then the last, minus square root of 3 times square root of 3 is 3. So this is over negative 1. So it's 6 radical 2 minus 6 radical 3. If I rewrite that, if I divide both parts by negative 1, I got negative 6 radical 2 plus a minus a negative 6 radical 3. Or you could even rearrange that and write 6 radical 3 minus 6 radical 2. That wouldn't be a bad idea either. All right. Number 12. Okay, this is a little confusing, but that is actually an index there. So we're talking 3x times, and I'm going to go exponential form. This is 2/3. And this is the first. Oops, the 3's still out here. The 3 is separate from this power, and that's 1 2/3. Now that's not as good as rewriting it in an improper fraction. 3 times 1 is 3, plus 2 is 5. So that's 3x to the 5/3 power. Here's the best answer there. And then 13, we're going to write that in radical form. And that's a to the negative 3/2 power. I'm going to write that as 1 over a to the 3/2 power. And then 1 over, that means a square root here, and an a to the 3rd here. It's in radical form now. And there wasn't any call to rationalize the denominator, like there would have been right there. So we're not going to, but if we were to do that, no, I'll just accept this. I won't take that any further. All right. Now, I'm multiplying here. I'm going to take the 4 times negative 3. I'll write this out. The x squared times x to the negative 1/3, and the y to the 3/2 times y to the 1/4. And negative 4 times 3, that's negative 12. Now we add the exponents with our common bases here. 2 plus negative 1/3. If I take a third from 2, that's 1 2/3. And I'll change that in a minute. Now 3/2, that is 6/4 plus 1/4. So my final answer, I'm going to write negative 12 x to the 5/3, converting that, and then y to the 7/4. Okay, now number 15. I'm going to write 27 as 3 to the 3rd. I'm going to write it as a power whenever I can, and that is to the 1/4 power. That's what that 4th root root is, and then the third root is the 1/3 power. And so when I go to write this, 3, I'm going to do this in 2 steps. 3 to the 3/4 power, that's the 3 times 1/4, and I still have this 1/3 on the outside. And then that's 3, the 3's cancel when I multiply that. That's 3 to the 1/4 power. So I'm simplifying and getting the 4th root of 3. That's what that is. All right, 16. We've got this polynomial expression here. It is subtraction. Don't FOIL. That's a mistake I see. Make sure you're looking that there is an operation that's not multiplication between the two. So I'm going to take 3x squared minus negative 2x squared. Then I'm going to take the negative 5x minus the 3x. And I'm going to take the plus 7 minus negative 5, just to kind of keep things straight and combining the like terms. 3x squared minus negative 2x squared, that's 5x squared. Negative 5x minus 3x is negative 8x. 7 minus negative 5 is positive 12. Okay. This one is one we're going to FOIL on. X times 3x is 3x squared first. Outside plus 2x. Inside minus 12x. And last minus 8. And those two terms in the middle are like terms. So I'm going to go 3x squared minus 10x minus 8. Alrighty. Now, you have different styles for multiplying. I'm going to go through and multiply everything by x first. Then I'm going to multiply all 3 terms here by negative 6, and then combine like terms. So 2x squared times x is 2x cubed. Negative 3x times x is negative 3x squared. And 1 times x is 1x, or x. Then negative 6 times 12x squared is negative 12x squared. I'll just write that down here right below the other. Negative 6 times negative 3x is positive 18x. And 6 times negative 1 is negative 6. Looky there. Everything lines up. 2x cubed minus 15x squared plus 19x minus 6 is what I'm going to call my final answer here. Now 19, you've got 2 options. If you know the cube coefficients, that's 1, 3, 3, and 1. Okay, and we will do this further, but I'll take the first term for each of these, and then I'll take the second term in the binomial on each term. The first term starts with this power and works its way down. And the second term starts with the third power on the right and works its way like that. And now that's just 1. And then we'll just put a plus in between all these. All right. 1x cubed plus 3 times x squared times 3 times y. So 3 times 3 is 9 x squared y. And this is 3 times, this is actually 9y squared. 3 squared, y squared. So 3 times 9, that is 27. Got x to the first, y to the second. That's 1, that's 1. 3 to the third power is 27, and y to the third power. Okay, your other option is multiply these two out, and when you get your answer, which should probably be x squared plus 6xy plus 9y squared, if you follow the pattern of squaring a binomial, and then multiply that by x plus 3y. Here's the first power, second power, third power. This is the answer, the product of these two. And then see if we get the same thing there. And then finally on number 20, I want to do this as a difference of squares. So I want to take the y minus 2 squared minus the x squared. Now y minus 2 squared, that's y squared minus 4y plus 4. You take the first term, square it. 2 times the first term times the second term is the middle term, and then the last term squared. And then I have this minus x squared. These are not like terms. We could rearrange it a little bit. Y squared minus x squared minus 4y plus 4. All right, there you go. As far as the review.